Friends, on behalf of My Retired Lad Foundation and other allied institutions, we extend a very hearty welcome to all of you for this very, very special session today on the global warming. And as you know, all of us know that the global warming is really a matter of concern, but it is a reality of the day. So the we thought that we'll keep a session, though very little is in our control, but whatever we can do, possibly we should do to look at this particular menace very, very seriously before it becomes a disaster thing for the entire planet. To talk on this particular session, we have a very, very eminent personality with us, Dr. Anil Bhardwaj, who has retired from the ONGC from a very senior position, and that's the Group General Manager of ONGC. And then he has been actively associated with the various social initiatives, particularly the environmental issues. He's also a prominent Rotarian from the city of the Navi Mumbai. So we thought that we would have his expertise on this particular subject. So on behalf of all of you, we welcome Dr. Anil Bhardwaj and request him to kindly take the floor. Bhardwaj sir, floor is open to you, sir.
Thank you, sir, for the invitation and introduction. I would like to share my thoughts and whatever I had learned on this topic of global warming with all of you. Uh, and if there are some questions, you can ask in between, or I will give a pause in between for questions also. The slide is visible.
Yeah, it's visible.
I'm audible and the slide is visible.
Yeah, yeah.
So,
Yeah,
today's topic is global warming. The roadmap of this presentation is like this: coverage by a journalist. That's what's in the news. Problem definition. Efforts which have been done globally to overcome this global warming. What's next possible? What can we do? That's all I will be presenting in this. So to begin with, I take you all back to 1977, where what was my experience. It was the year 1977. I traveled from my hometown, which is in Haryana, that is Yamunanagar, to a hill station nearby, the place called Dehradun. Its altitude is around 2000 meters, and in those days, it was a cherished hill station, and weather used to be very nice. Even in the summer season, sometimes one may not need a fan. And whenever there was hot weather for 2 to 3 days, it used to rain. And there was no question of heat waves in that area. Then I joined in 1983 ONGC. Its headquarters is in Dehradun. By that time, fan was very common. Some people had started using coolers, and the summer was very hot, though it was tolerable. In 1990, I left ONGC. I was transferred from ONGC Dehradun to Mumbai. And the year 1990, when I left Dehradun, ACs had started coming to homes, whoever could afford it. Heat wave was felt, and the weather between 1977 and 1990 was entirely different. Today, whenever I visit, I find that it's very hot in summer. Whosoever means maximum people are trying to have the air conditioners nowadays, and heat waves are frequent. Rains are not that frequent. So many things have changed in that city, which I closely watched over some 20 from 77 to till today. Reasons many. Some amongst them is increase in population in that area. Then vehicular traffic is now too much there. Some forests have been cut. So a lot of those things which are related with global warming. So I could locally feel that what's really happening. What we nowadays always find that summers are very hot, and then there are erratic rainfalls. Those areas which never had a rainfall now have floods sometime. Unpredictable climate is there. And most of you might have seen this chart in the newspapers recently. It is on 19th of May. World's 100 hottest cities were all in India. So I'm not focusing that it's in India. What I'm focusing is that hot cities are there nowadays, because it's summertime for India near to the equator. So that may be the reason that India has this focus of 100 hottest cities. But all over the world, the situation is similar. There was a conference of parties 27, which was held in November 22. They are 119 and 189 countries who had that meeting, and they reported that many countries are experiencing accelerated glacier melting. More than 1,000 glaciers in Tajikistan area have completely disappeared. What is the significance of disappearing of these glaciers? These glaciers supply water to the Central Asian regions. So decrease in water, melting of the glaciers means discontinuous supply of water for that particular region, then effect on the agriculture and availability of potable water. In close to our country, in India, the glaciers in this Gangotri glaciers, this has been receding over the years, and this glacier is very important for the Ganga basin inhabitants. Again, agriculture is linked to that, water supply is linked to that, and habitation is linked to that. So what is the effect of this all when we say that global warming is happening? First, that global average temperature in the pre-industrial area was around 13.7 to 14. That is from where we have the baseline. And current temperatures now significantly above this level, often exceeding 1.5 degrees centigrade warmer. So for us, it's only 1.5. It is the global average which is being accounted. It is not linked with a particular place. This 1.5 degrees centigrade global warming has a significant influence in different ways, which is shown here in the chart. For example, we go to the last row. It says that if there is a 1.5 degrees Celsius rise in temperature, global average temperature, then what will be the effect? At least once every 100 years, there will be sea ice free summers in the Arctic region. And if the global temperature rises by 2 degrees Celsius, then at least once every 10 years, there will be sea ice free summers in the Arctic region. So that means the condition will be 10 times worse because of the only 0.5 degree shift in the temperature, only 0.5 degrees Celsius rise in temperature. Same way, extreme heat. 14% of the global population will be exposed to severe heat every 1 in 5 years. And if the temperature rises by 2 degrees Celsius, 37% of the global population will be experiencing that heat. So all these kind of things will be happening when there is a further shift in the temperature, further rise in the temperature. 1.5 degrees Celsius has already made an impact, and if it is further rising, then it will have still worse effects. So what is it linked to? From 1760 onwards, there is data about carbon dioxide in the atmosphere, and in the pre-industrial area, it was around 278 parts per million of the air. And today we have around 417, and the latest figure is around 426 parts per million of the atmosphere. So gradually there has been an increase, and if in terms of the absolute terms, we see that there is a rise from 278 to 417, around 15%, 50% rise in the carbon dioxide concentration in the atmosphere. With that, then there is a uptrend in the global average temperature also. As of May 26, carbon dioxide in Earth's atmosphere was 432.5. That means around 50% more than what was in the pre-industrial area. There has been a time when there is a steep rise in this carbon dioxide concentration in the air, and that was from the 1960 onwards. There has been a very rapid growth in several activities around the globe, or industrial activity, vehicles, and electricity. All those combined together led to a very rapid increase in carbon dioxide concentration in the atmosphere. Parallel to that, what goes is the global fossil fuel consumption. And if we see from 1900, it is from again 1960 onwards, there is a steep rise in the fossil fuel consumption. This fossil fuels, we include coal, gas, and oil. And why they are important? Because when they burn, they give carbon dioxide. And carbon dioxide is one of the gases which causes the global warming. I will mention in detail about how this all happens in the subsequent slides. Now, let us have a look at the Indian figures. The trend of the four wheelers in India has been very slowly rising when there was a license era in the beginning, and in 1980 came the 83, I think 83 or 84 came this Maruti, and then the number of cars increased. After that came the globalization and liberalization, and then we have a steep curve in the four wheelers. And air conditioners also, with the liberalization era coming up and more industries being set up and encouragement for the consumerism, again there is an increase. And how it is, but over the period of time, population has also grown. So combined, all these effects have led to uh, a scenario which here shows for India, but that is applicable globally. Now, I will just mention a few small things about what is the background of this global warming, some physics and chemistry of this. Fossil fuels, whether we say coal, oil, or gas, they are formed because of the fossilization process, in which under the temperature and pressure the organic matter decomposes and gets converted into one form is called coal and the other form is called the oil and gas, or the hydrocarbons. So plants, etc., they give you the coal, and then marine life that gives the petroleum and natural gas. Now, these carbon dioxide is all around there in the atmosphere. It is not only that our anthropogenic carbon dioxide is there, it is other processes also generating carbon dioxide. So there is a cycle in which whatever carbon dioxide is produced, that is absorbed by some natural sinks present in our nature. These sinks are seawater and the forest. Whatever carbon dioxide is generated, for around 50 to 60% is absorbed by these natural sinks, and whatever cannot be absorbed, that goes into the atmosphere. So over a period of time, what has happened is that whatever was converted from the plant and animal life into the hydrocarbon forms or the fossil fuels, by sequestering the carbon from the surroundings and depositing as fossil fuels, which happened in millions of years, we are burning that in a short spell of time. So the nature doesn't find the time to equilibrate with the natural sinks, that is seawater and forests. And as a result of that, carbon dioxide is remains in the air and the atmosphere, and that uh, keeps on accumulating and the concentration keeps on increasing. So, what is the effect of this global warming? There are multiple effects. Melting of glaciers, I showed. Then, subsequently, it can rise when the glaciers will melt. There will be sea level rise. There are extreme weathers. Wildfires are there when it is hot. Agriculture is affected. Sometimes more water, sometimes less water. Then there is an effect on health. Diseases pattern will change, and the net result of that is a final impact on the economy. And when we say the final impact of on economy, that is the if the bottom of the pyramid is most affected by this impact on the economy. And the sustainable development goals, the first goal is that there should be no poverty. So, our environmental effects, our global warming, climate change, all has gets linked to the financial status of the inhabitants on the earth. And first and the important sustainable development goal given by United Nations, which was set up in 2015, is that no poverty, and our activities will be adversely affecting the achievement of this goal. Just what is we call sustainability, so that we are on the same page. Sustainability is the practice of meeting the needs of the present without compromising the ability of future generations to meet their own needs, emphasizing a balance among environmental health, social equity, and economic vitality. This definition of sustainability was given by a committee set up in which submitted its report in, I think, 1987, wherein which this committee was led by Norwegian Prime Minister. Our common something uh, planet. I think I have the slide on that. So sustainability so encompasses in it carbon emission reduction as a critical component. Carbon emission, when we say the carbon dioxide. So what makes all this happen? Let us see. It starts with the electromagnetic radiation spectrum, which is there in the sunlight. With the sunlight, we get the visible spectrum. This visible spectrum has the light which can make us see, and also there is some ultraviolet light. This is on the left hand side is the infrared, on the right hand side is the ultraviolet. This is the low energy light, this is the high energy light, and when we compare all these three, sunlight or the visible light is the intermediate, but it is a compared to infrared light, it is a high energy light. Now, how this is significant will come in the next slides. Now, heat energy, which comes to moves via three primary methods: conduction, convection, and radiation. What comes to the earth from the sun is by the mode which we call as the radiation, because the sunlight, the visible light, is an electromagnetic light. Therefore, it can travel through the vacuum. Above the atmosphere, there is a space, there is a vacuum where there is a vacuum. So it can travel through the vacuum and directly reach the surface of the earth. And when it reaches the surface of the earth, this heat is transferred to the earth's surface. Then, whatever heat the earth's surface gets through conduction, it supplies to the whole of the earth, inside the earth, and also it goes to the gases which are around the earth, that is the atmosphere of the earth. Now in this, then this is by the direct contact. Then there is a convection currents which are set up in the gases, and they transfer the heat to other gases which are just above this surface of the earth in the atmosphere. So the heat of the sun has come to the earth, got transferred not directly but indirectly through conduction and convection to the atmosphere. Now when this heat goes back, some of this light, these radiations which are high energy, they are able to go out of the atmosphere of the earth. Now in this atmosphere there is carbon dioxide and other gases also. So some of the light energy radiation, the radiations which have high energy, they can go back. Now this, when the light strikes the earth, from here it comes from the sun. Sun is at a temperature of around 5500 degrees Celsius. So it emits the high energy radiations. Earth absorbs that heat. This temperature of this earth is much less as compared to the temperature of the sun. As a result of this, it emits radiations which are low in energy. Now, this low energy radiations, one of them is infrared radiations. These infrared radiations, when they go back out of the atmosphere, they collide with the greenhouse gases, carbon dioxide, water vapors, methane, and many other gases. The energy of these waves is such that it can cause a vibration in the bonds of these molecules and gets retained there within these greenhouse gases and is not able to escape. When this energy is absorbed by these molecules, they transit into a higher energy state, but soon they release back that energy, and that energy is released back into our atmosphere. So this is the whole thing, what happens when the heat comes and reflected and then comes back into the atmosphere due to the presence of these greenhouse gases. More of these gases, more of the energy, heat is trapped, and more is the heating of the environment. Gradually, when the carbon dioxide is increasing, the intensity of absorption and reflection back into the atmosphere is increasing. This all happens in the troposphere, which is around 12 to 18 kilometers from the surface of the earth. What are this weather and winds, all these things, this happens in this, and these gases or the greenhouse gases are trapped in this troposphere. So this I had shown that what is the relation between sun, earth, and atmosphere, that greenhouse gases absorb all this energy. We are able to experience this greenhouse effect if we close the glasses and the doors of the car and come back. It's hard, very difficult to touch even the steering of the car. So that goes. Now this is without these are the greenhouse gases pre-industrial era, and these are the gases, greenhouse gases in the current era, when the thickness of this greenhouse gas layers has increased. It is not that these greenhouse gases are not required. They are required. Without greenhouse gas, the average temperature of Earth would have been minus 18 degrees Celsius. So because of the presence, this has our temperature is what is around 13 degree, and over the years this temperature has been maintained, and our style in habitation, crops, and ecosystem balance has occurred now around that 13.5 14 degrees Celsius. We are causing that change by emitting the greenhouse gases, and because of that there is some imbalance in the ecosystem. That is what is worrying. what are the different gases which can cause this greenhouse gas effect? They include carbon dioxide, methane, oxides of nitrogen, hydrofluorocarbons, which are used in the refrigeration, polyfluorocarbons, sulfur hexafluoride, and nitrogen trifluoride. These are some. And the greenhouse warming potential of these greenhouse gases are different. Carbon dioxide is given as one, then compared to that, others have a higher potential. But where they are not a cause of much worry, because the quantities released are much less as compared to what is released as carbon dioxide. Now, greenhouse gas distribution in Earth's atmosphere, surprisingly for many, that water vapors are also a greenhouse gas. When it is in the vapor form, it is gas. This is 60% of the atmosphere, and we don't talk about it. We talk about carbon dioxide, methane, ozone, and others. Why we don't talk about water vapors? Because they also absorb the energy, and they also cause a greenhouse effect. And over the years, they have been present there. And because of that, our Earth's temperature has been maintained, what I mentioned, around 13-14 degrees Celsius. Now, water vapors behave differently as compared to carbon dioxide. They stay in the atmosphere for only a short period, few days, maybe around 10-15 days. And after that, these water vapors condense as rain or snow and fall down into the sea on the on the earth. And this balance of water vapors has been there over the millions of years. But carbon dioxide accumulates there. It does not, part of it goes into the natural sinks, and whatever doesn't go into the natural sinks, that stays as it is. So that is why it becomes more important, and that is why it is important, and water vapors are not important. When we remove the water vapors, then carbon dioxide is the highest percentage of greenhouse gas which is present in the atmosphere. So what has happened over the period of time? Since the industrial area started, we started using coal, steam engine started, and the carbon dioxide was emitted. Then came the transport. Along with that, production of the steel. In the production of steel, a lot of carbon is used to convert oxides of iron into iron, and that added to the carbon dioxide. Then came around 1860s, petroleum, and that further added the carbon dioxide and included the methane. Also was released. Methane is released in many other ways, but this is also adds to that. And with that, the transportation and industrial growth became very aggressive, and as a result of that, we find that from the era, the liquid hydrocarbons and hydrocarbon gases came into practice, the emissions of carbon dioxide and global rise in temperature has enhanced as compared to what was in the just after the industrial era, maybe up to 1850. But after 1860, there was a jump, and then after 1960, again there was a jump. This table just shows that what happened during what era. There was the age of coal, then was the industrial expansion, rise of oil and gas, and the modern compounding, when the consumerism is at its peak. Everything is now available and one can afford, and therefore all sort of polluting fuels are being used to the highest extent. Uh, it's not that we came to know recently about this global warming and greenhouse. Greenhouse effect theory was proposed way back in 1824 when the plants were grown in a covered area during the winter time so that the temperature could be maintained for their growth. Then demonstration of carbon dioxide is absorbing the heat, that also came to be known in 1856. 1859, there was identification of greenhouse gases other than carbon dioxide also. As early as 1896, there were information that human caused warming, that was done by Arrhenius. And then came in 1938 evidence of industrial warming presented by Stewart Callender. During 57 to 58, proof of carbon dioxide accumulation in atmosphere was established. In 1987 came that Brundtland report, which I was mentioning, Our Common Future. This was under UN World Commission on Environment and Development, which showed that there is impact of our human activities on the future of human beings. In 1992, there was establishment of United Nations Framework Convention on Climate Change. And then came the 1995 first conference of parties under this United Nations Framework Convention on Climate Change. So every year now this conference of parties is held to discuss that what has been achieved, what needs to be achieved, where the corrections need to be held. This is some paper I have shown. It's some interesting for those who are into the research and academics. This paper, which was presented by Eunice Food, prepared by Eunice Food, showing that carbon dioxide absorbs energy. This was to be presented in American Association for the Advancement of the Science in 1856. That time, she was not allowed to present the paper because she was female. The paper was presented by her colleague in this conference, not by her, because they were not allowed to attend the conferences at the time. So globally, there has been many other changes which have happened. Now, coming to top global greenhouse gases emitters. As on date, China stands at the top in terms of the share of carbon greenhouse gases emissions. India comes the third, and European Union is fourth. If we see this table, during 2023, then per capita greenhouse gas emission by China is 11 tons of carbon dioxide equivalent, USA is 18, India is 2.9. Here, if we see, it is contributing 7.8% and stands third in terms of the percentage of share, but average per capita emissions are much less as compared to the global average also. The global average stands at around 4.8 metric tons, and in 23 it was 4.76 from the data of 189 countries. So compared to that, India's average is much less, but because of the numbers, we are third largest contributor of carbon dioxide greenhouse gas emissions every year. The global trends, how they are moving for the past 20-25 years, the advanced developed countries, it is coming down, whereas in the developing countries, it is on the increase. because the developments are taking place, and the developments, when they are taking place, there is an energy requirement, and energy, coal is still the highest source of energy, especially electrical energy, and it is also the worst polluter. So therefore it leads to the uh, gradual increase in carbon dioxide emission in the developing countries. Uh, Sources of man-made greenhouse gases in the Earth's atmosphere, if we see that, uh, power generation is the number one, deforestation in the number two, road transport is the number three, oil and gas business for other things, fertilizer production, livestock, that is our meat industry, is again significantly contributing. Then iron and steel, cement, air travel, garbage waste, what we throw and it decomposes, and methane is emitted from that. So there are different industries, but three top ones are deforestation, power generation, and road transport. Mostly in that is carbon dioxide. Again, coming to the sustainable development goals, one of the goals which have been set by United Nations is affordable and clean energy. If we see this slide, if we have clean energy, here also the clean energy, lot of reduction in greenhouse gas emissions can be done. So again, the Sustainable Development Goals says that affordable and clean energy. Affordable is first point. I just will give you some fact from the history. In around 1950s, late 50s or early 60s, the cost of production of 1 watt of electricity from solar panels was around $1,000. $1,000 for 1 watt, 1 unit. And now it has come down to even around 2 rupees per unit. So when they say that affordable, now it has been made affordable and it can be used, and that is what is making a impact in the reducing greenhouse gases emission globally. And another thing which is the it stresses is in sustainable development goals, industry, innovation, and infrastructure. In this, innovation is a very important word, that over a period of time there have been innovations taking place which are helping to reduce the greenhouse gases emissions and reduction. And in this goals, then there are set some targets, and those targets then have some KPIs. With that it moves, so that there is access, sustainability, and efficiency uh, to make clean energy available for all. uh, this slide tells about how the carbon content of the different fuels varies, or the hydrogen carbon ratio. So if we have coal, in this, hydrogen carbon ratio is the lowest. Or if you make it reverse, then carbon is the highest in case of coal, and carbon is the least in case of the natural gas. Because of that, it helps in how much gas will be, carbon dioxide gas will be emitted during their combustion. So the same graph has been put in the reverse way in this table. So the carbon hydrogen ratio has been written. So carbon hydrogen ratio is the highest in the case of coal and is the least in the case of natural gas. So burning of the natural gas gives us less of carbon dioxide, where coal is the worst polluter. Same thing. So what steps have been taken globally what actions have been taken that for decarbonization or minimization of carbon dioxide. One is the renewable energy, whether it is solar or wind or hydroelectricity. Then use of electric vehicles. Nuclear energy, though, always remains a controversial, but it is a least polluter. Then energy storage. With the renewable, we have a issue that we cannot store it. So energy storage is being encouraged in the form of batteries. Then carbon capture, utilization, and storage for removal of carbon dioxide from the atmosphere. So carbon dioxide will be captured, and uh, it will be stored in the reservoirs which will be suitable, and also this carbon can be converted into some other useful molecules. Sustainable fuels. There are now sustainable aviation fuels which have been developed on the basis of oil which is used for cooking, and it can be no more used for multiple cooking. That oil is taken and converted into useful aviation fuels. And New Zealand has done a marvelous job in this case. India has also done. There is a Indian Institute of Petroleum in Dehradun. They have done a lot of work on that, and now their process has been standardized, and it is efforts are being made by Indian Oil to have it on the commercial scale. Circular technologies, not new to India. Don't let anything go in waste. If it can be reused, recycled, let us do it. Hydrogen, we hear a lot, but with hydrogen, there is a one problem. It is not a primary source of energy like we have coal, oil, or hydrocarbon gases. So we have to generate it first, and then we can use it. And once it is used, it does not pollute. But generation of hydrogen in itself is a big challenge. One of the methods which is being now what we very often hear, that is the green hydrogen. That green hydrogen comes from electrolysis of water, and electricity for that is the solar electricity. So daytime when we have excess of electricity can be used to convert decomposed water and get hydrogen, and that hydrogen will be stored and can be subsequently used. Electrical heat, it's more efficient, so it improves energy. Efficiency improvement is another which will help us in decarbonization, conservation, and exergy analysis, means we don't allow any heat to go waste. With the starting of the electric cars, there has been reduction in the carbon dioxide related to the mileage these cars travel. One is that I'm just here presenting the how our usage of paper gets connected with the global warming in by deforestation for to get the trees for manufacturing paper. Paper is manufactured from trees, pulp of the tree. There is some material of the tree which is not usable, that is separated, and then the pulp of the tree. One tree gives around 20 reams of 80 GSM A4 size paper. During our lifetime, most of us cannot plant a tree and make it survive. Bottom line is make it survive. We can plant many trees during the monsoon. Here, many go for planting the trees, but how many of them survive? Can we save paper to that extent during our lifetime? Recent trend, there is a, tissue paper is the highest consumer of trees. Can we reduce them? Can we not? Can we avoid unnecessary usage? We are too liberal about using the tissue paper, especially when we don't have to pay for it. Important. Carbon footprint of our journey. If we are going from Delhi to Mumbai, Chennai, Kolkata, then by flight, we emit so much of carbon dioxide. And there are some calculations. There are two calculations by flight. One gives this and one gives this. If we go by rail or train, it is only 13.05. So if we go by bus, it increases. And if we go by car single or 1.5 persons or 2 persons, so what we see here that by using a means of transport, there is a possibility of changing the carbon footprint of our journey. Some numbers about how much carbon dioxide we emit. 1 unit of electricity emits about 0.727 kgs of carbon dioxide. This will depend upon from where the electricity is coming. This is an average. Most of the electricity suppliers these days have been mandated to use renewable energy also as a component of their total electricity supply, along with the electricity generated from the power generation power stations. Diesel 2.64 kgs of carbon dioxide per liter, petrol, LPG. Then one tree captures about 14 kgs of carbon dioxide per year. So it's not possible to make to grow the tree and then make them consume all the carbon dioxide which has been generated. So one tree will be able to capture carbon dioxide emitted in generating only 19.25 units of electricity. So only. So if you are consuming more than one tree is not sufficient for that. Just how much carbon dioxide we emit in a year. In our electricity bill, we can know how much of units of electricity we have consumed in a year. Then units of electricity I consumed in 1 year was 2,600. Taking 1 unit of electricity emitting 0.727, carbon dioxide emission due to my consumption of electricity is 1900. I consumed 474 liters of petrol in 1 year because I don't stay here. So that is, I stay less here. Therefore, my car uses less of petrol. And to that account, there were around 1200 kgs of carbon dioxide. So total, my annual emission was 3100. So that way, we become accountable. And if all these kgs of carbon dioxide has to be absorbed by trees, I will need somewhere around some 200 plus trees to capture this much of carbon dioxide in 1 year. So you can see the complexity of the equation. So the choice is ours. We allow the business to run as usual, or act, or there is a corporate collective responsibility. I had shown that there is a final impact on the economy. So what have been Dr. Sangupta sir, I think I will be taking slightly more time, maybe another 10 minutes. Should I continue or sum up quickly?
I think you can sum it up and then take a question.
Okay. So then I take you to the slide where I can sum up and then take up some questions. There are many efforts which we can make, and most of the time we think that whether my efforts will be significant or not through some equation. If we don't make any effort throughout the year, situation remains as it is. If we make even a small effort, it becomes 1.4, and much more effort, much more results. So small contributions, small efforts by all of us can have an impact over a period of time. If the curve was supposed to go like this, at least we can make it like this. Small actions by a lot of people can make a big change. So let's simply multiply small efforts, whatever we can do. At higher levels, I had shown you what efforts have been made. So let's not feel shy about making whatever efforts we can. remember that hidden cost of carbon emissions is climate-induced disasters. Thank you.
Thanks a lot, sir, for that excellent exposition and insight on the subject. Now the floor is open. Members can unmute, and if they want to ask any question, most welcome.
Sir,
Yes, sir.
myself R.K. Modi.
Hanji, sir.
You have shown all the reasons for carbon emission
Yes, sir.
and effect of this.
Yes, sir.
Can we guess the carbon emission effects of the war, modern war?
Oh, sir, there can be made an estimates about this, that what are there on the basis of what kind of warheads they had and what quantity of that. It is possible. It is possible, and there will be good guesstimates in that.
And I think it is contributing significantly.
Definitely there will be a significant, because wherever there is it will be from the back end till the front end, whatever was industrial effort in manufacturing them, that will be added to that, and then whatever heat is generated, that heat generated results in some if there is a fuel consumption, of course there has been a lot of fuel consumption. Because of the heat, there will be some oxides of nitrogen which will be generated, which will be again causing the greenhouse gas effect. So it is possible to give a good guesstimate. For example, I tell you this IPL matches which are conducted. These IPL matches have a carbon footprint. There are calculations available for those IPL matches, and in fact, there was a mention that we should reduce this carbon footprint of these IPL matches.
Okay, thank you.
Thank you, Agarwal. Can I ask one question, please?
Yes, sir. Yes, sir. Yes, sir.
Sir, the question is, your paper is a very well presented presentation. So thank you for that. Now, my question is, with the growing requirement of development and all business activities increasing, population increasing and all that, lot of area is being cut, trees are being cut to provide for the making of those buildings and things like. Now, if that is the situation, then to what extent can this situation be reversed in the terms of creating carbon capture capacity? Because as you said yourselves also, that it takes a lot of time to grow the trees. In fact, some of these things like, mangroves and all that, they are very difficult to regrow. And another thing is, as some of these big countries like America, Australia and all that, they said that we cannot reduce our way of living. So they will continue to produce whatever type of greenhouse gases they're producing. Now, in this situation, how is this going to be taken care of? And similarly, for storage of solar energy and all that, the efforts to produce a storage system is becoming huge. And it is taking a lot of time also, and a lot of money also is required for that. A lot of research is going on. I'm aware of that. So any comments on that, please?
Dr. Rajendra Pachori, many of you might have heard the name. He was the director of TERI, the Indian Institute, and he was also heading the International Panel on Climate Change. During his time, one report was issued, and one of the statements he had made in that report was to bring the world to a sustainable level, we will have to change the way we live. That was a remarkable statement made by him in that report. Like you, those who go deep into this topic, think about it. and everybody has the same apprehension what you said. It is becoming very difficult to reverse. First, when we say that the growth means it brings all these kind of things with it, and consumerism with it. And as I had shown you that curve, the usage of ACs, vehicles, all going up and up. And every company, every manufacturing company wants to show its graph rising every year by year. So there is a conflict between one way what we see and one way what we want. Efforts are being made by those who think on this subject that we should improve upon this, find out a ways like the so. Just imagine. I will just show you a picture. I'll show you a picture which will. Are you able to see this picture?
Yeah.
This is a toy train in Darjeeling. There are two toy trains running, one with diesel and one with steam engine. Now in India, all the railways are almost on electricity. For emergency, for special operations, there are diesel engines, and there are no steam engines or coal engines. So this much of effort has been made. So effort, had it been like this, you can just imagine what would have been the situation in India when so many trains are running and all running on coal. Are all the electricity demand being met by coal-powered power generation system? So efforts are there which are helping, and at the same time, what you have said is correct, that we have to make a drastic changes. And again, if you go back to the slide which I had shown, that our thoughts also have to play in this, that whatever we think, we must also do that.
Thank you.
Shall I ask one question?
Sure, sir. Sure.
Yeah, my question is very simple. Sir, for domestic purpose, some people use LPG and some people use pipeline PNG.
Right.
So, yeah, if you compare the both of these, which emits more carbon dioxide?
LPG will emit more carbon dioxide because LPG is having butane and butane and propane, whereas compressed natural gas has methane only. So the hydrogen content of natural gas, compressed natural gas, is more, so therefore it emits less for the same amount of calories which you have to generate.
So that CNG and PNG are same. CNG we are using for domestic purpose, while CNG for the vehicles. Both composition is same.
CNG is compressed natural gas. PNG is piped natural gas. So both are natural gases. The only thing is that pressures matter, that under what pressures they are stored.
Okay, sir. Thank you so much.
We'll take one more question. Anybody else? So, Dr. Anil Bhardwaj, that was an excellent and outstanding session. We thank you very much on behalf of all of us present over here, and those not present over here also, because we'll send them through the YouTube posting. Many, many thanks for a deep insight and words of advice that what we should do, what we can do, we ought to do. I think that's the underlying message here today, etc. Because the planting of the tree is not the solution. Solution is we try to reduce the means and I mean to say the sources of the carbon dioxide emission and other gases emission. So thanks a lot for your time, and thank you very much to everybody over here. Thanks a lot.
My pleasure. Thank you.
Thank you so much.
Thank you, sir.
Thank you, sir.
Thank you.